Okay, I'm going to try to show method 1, which is going to be solving these average mass problems by using for every statements. I will then show method 2 also, which is similar to what we already did in the packet, Mary's method and Jack's method. And you can kind of take your pick which one you would prefer. So for this, the idea is that we're trying to figure out, just like any other average, we're trying to figure out how many total things there are and how much total that they weigh. And so for every statements will really let us do that pretty well. So I'm going to start off and I'm going to say for every, and here's where I need to talk about how many atoms I have. It does not tell me how many atoms I have. However, it does give me percentages. And those percentages are percent counting. So just like what we've done with percent by mass, and we said 75% by mass could be turned into 75 grams, I'm going to turn this 75% up here into a number, meaning for every 75 atoms. And those 75 atoms, I need to figure out how much those 75 atoms weigh. Now in this problem here, it's really asking, when it says x equals 40, oh, that was bigger than I anticipated, x-40, that means this isotope, this element, has a mass of 40. So it could be calcium 40 or scandium 40 or potassium 40 maybe. We don't know. But the point is that that individual isotope weighs 40. But I have 75 of these atoms. So I need to pull up my calculator real quick, even though I could do this by hand for sure, just to show you. 75 times 40. We have 75 atoms that each weigh 40. So I'm going to put in that these atoms weigh 3,000, and again my unit for atoms is AMU. Now the way that I would have done that by hand is to say 75 times 4 is 300, and then add that extra 0 back on there. And then for my next isotope, I have X45. And it happens 20% of the time. So that means I'm going to say that this 20% is 20 atoms. And those 20 atoms would weigh, one of them weighs 45. So 20 of them would weigh 45 times 2 is 90. So 45 times 20 is 900 AMU. And I have this other isotope, X42. It happens 5% of the time, which means that 5 atoms weigh, again, one atom would weigh 42, so 5 atoms is what I'm figuring out here. 5 times 40 is 200, so 5 times 2 is 10, so 5 times 42 is 210 AMU. And here's where my there is going to come in. How many, now I get my total. How many total atoms do I have? Well, this is pretty easy because since this was a percentage, I have 100 total atoms. And here's where I would want to know how much they totally weigh. And this is, again, every average you've ever done, you needed to know how many there were and then what the total was. So those are the two parts that we've been able to figure out. So I'm going to do 3,000 plus 900 is 3,900 plus 210. It gives me a total of 4,110 AMU. So now I'm going to make this a little bit smaller here. And then I'm going to shrink my font so I can get it all onto one line, just to make it a little bit easier. There we go. Now what my average is really saying is how much, when we say what is the average atomic mass, we're saying how much on average does one element weigh. So that means out of all this, what I really want to say is 100 atoms weighs 41 AMU. One atom weighs blank, which means I am dividing by 100, which means I am dividing, by 100. So, and whenever you're dividing by base 10 things, I can move the decimal point over 2 spots, and I get 41.10 AMU. Now, I can really easily check my answer a little bit here because I know that my lowest possible value was 40 and my highest possible value was 45. So my answer definitely had to be in between 40 and 45, and it is. So that's one good way that I can check my answer. The other way that I can check it is that my most common one, which is 75% of the time it weighs 40, is going to be, that's going to really heavily skew the average. Just like if 75% of the time you get a 40 on a test, that's going to be not so good for your grade. So the fact that it is much closer to being 40 than it is to being 45 also tells me that I did it. Okay, now let's do it the other way. So I'm going to do from page 17 in your packet here, I'm going to do Jack's method. Not that that is a real method. Jack's not a real person, but take this down a little bit here. I'm going to say how much it weighs, 40 AMU, times how often it occurs. And again, this is 75%, and typically when we do math with percentages, we make them into decimals. When here's the part that I think people are going to maybe get mixed up on, is that that is telling us how much weight that is contributing to the total average. And this is again similar to kind of your grade. And then 45 AMU times 0.20 plus 42 AMU times, be careful with your decimals here, 0.05 as a percentage. And then that all together will get me my stuff here. So now, this is definitely less writing, but maybe less understanding as well, which would not be a good combination. But 0.75 is 3/4, so 3/4 of 40 is 30, plus 0.20 is either 1/5 or 2/10, so a fifth of 45 is 9, or a tenth of 45 is 4.5, doubled makes 9 AMU. And then 0.05, so that's half of 0.10, which is a tenth. So a tenth of 42 is 4.2, but I need half of that, which is 2.1 AMU. And altogether, it still gets me the same exact answer of 41.10 AMU to compare back to this one. So what I'd like you to do now is try the second problem on the sheet. If you're going to use for every statements, you can go ahead and start all the way down at letter C, because we don't need to know the percentages in order to solve this. We don't need to know how much it weighs because it tells us that in the data table right there. However, if you're going to use the decimal weight, you're going to need to solve for the percentage. You're going to need to solve for how much one individual one of those things weighs. So pause the video right now, try the second one, and then I'll resume it. Okay, so I'm assuming that you have now solved the problem and we're just kind of trying to check your answers. So here we go. I'm going to solve it using the for every statement way. I make it nice and small here. I'm going to say for every, oops, that's a little bit too small. For every, first we have 150 beans or atoms. They weigh 600 grams, and 450 beans weighs 900 grams, and 300 beans weighs 750 grams. There is, here's where the nice part is. Now this one wasn't a percentage, it didn't need to be a percentage. I can just add up my total number of beans. So 450 plus 150 is 600, plus 300 gives me 900 total beans, which weigh 750, 900, and 600. So 900 and 600 make 1,500, plus 750 makes 2,250 grams. Then I'm going to do my next for every statement right down here. Get small. I want to know how much one bean weighs. Blank. Which means I am dividing both of these by 900. Which is not the nicest math here, but it's not horrible. So I would do 2250 divided by 900. Now if you wanted to, remember that we could basically cancel out a 0 on each of these. And we could do 2250 divided by 900. We could do 225 divided by 90. Or we could do 22.5 divided by 9, which is probably what most people would rather do in their long division. So 9 will go into 22 twice, which makes 18. Carry the 4 down, bring the 5 down. Here's my decimal. 9 goes into 45 5 times. So the average bean weighs 2.5 grams. Let's look at it the other way. Percent abundance is just how often does it occur. So we're doing 150 over the total number of beans, which is 900, which works out to be about 16.67%. It is a sixth. Bean number 2 is 450 over 900. Right, 6. This is 50%. That one's easy. And bean number 3 is 300 over 900, which is 33%. The mass of a single atom. So if 150 beans weigh 600, I can do 600 divided by 4. An extra 0 there. Or excuse me, divided by 150. Sorry. Equals 4. I can do 900 divided by 450 equals 2. And I can do 750 divided by 300 equals 2.5. So again, all we're really saying is for every 450 beans, there are 900 grams. For every 1 bean, there are 2 grams. Okay, but now we could do that official process here, and with the decimals. So I'm going to make that be for every. Oh, I'm not doing. Sorry, I'm not doing for every. So on this one, I am doing the other method. So I'm going to take my percentage as a decimal would be okay, or I could just do it as a fraction, either one. So, but I'll do it as a decimal here. So 0.16 times 4 grams plus my next percentage is 0.5 times 2 grams plus my next percentage is 0.33 times 2.5 grams, and all of that all together will still equal 2.5. So either method works. I'm okay with you using either method. For some people, I'm a little concerned about if they know for sure what that number means and what that number means and what they're really doing, that they're not going to forget that plus sign or that minus sign as you go through. So now please work on pages 11 through 14 in your packet, and I'll try to clear up anything tomorrow. Thanks.